Now that we learned about the inner product and inner product space, we are interested in knowing if we define a new function, this new function is an inner product or not. The inner product that we just defined says, hey, I'm multiplying the first components, and then I add 2 times the multiplication of second components to it. Is this an inner product? Is this function an inner product? We need to check these axioms. Check the axioms. So first of all, we need to show that U and V, the inner product, is equal to the inner product of V and U. Let's put a question mark in front of it. We know that this guy on the left-hand side is U1 V1 plus 2 U2 V2. On the right-hand side, however, we have V and U. So it is V1 U1 plus 2 times V2 U2. But this is just multiplication between elements, all right? We can switch them around. This is basically U1 V1 plus 2 U2 V2. They are equal to each other. So we don't have any issue with the first axiom. Let us move on to the second axiom. The second axiom says you have U, V plus W. On the right-hand side, you have U and V plus U and W. So left-hand side and then right-hand side. This is your left-hand side. If you need to find the inner product between U and V plus W, this guy becomes U1, V1 plus W1 plus 2 times U2, V2 plus W2. You can write this in expanded form, right? This is just U1 V1 plus U1 W1 plus 2U V2 plus 2U W2. This is my left-hand side. Now on the right-hand side, what do I have? My right-hand side says, hey, I have U1 V1 plus 2 U2 V2 plus, now the inner product between U and W, U1 W1 plus 2 U2 W2. Compare these two. U1 V1, 2 U2 V2, basically here. U1 W1, 2 U2 W2. But basically the same thing. So the second axiom also met. Number 3 says, well, here you have C, inner product of U and V. Is this equal to CU and V inner product? So on the left-hand side, we have C, open parenthesis, U1 V1 plus 2 U2 V2, which is basically CU1 V1 plus 2C U2 V2. On the right-hand side, we have CU and V. It means that you have C U1 V1 plus 2C U2 V2, because CU is basically CU1 and CU2. Well, let's just check these two. CU1 V1, they are the same. 2CU2 V2, they are the same. So far the first 3 axioms are met. What about the last one? Number 4, we need to form the inner product between U and U, which is basically U1 U1 plus 2 U2 U2. So basically you are finding U1 squared plus U2 squared, which is always positive. It is 0 if and only if coordinates of U is 0. So we just showed that these 4 axioms they all met. So the plane, along with this function that we just defined, forms an inner product space.